Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Najmi bin Iswandi. My student ID is 2022846612. I from Group 1. Next, I will introduce my group member. First, Ahmad Wildan bin Muzlaha. Second, Muhammad Iman Syahmi bin Abdul Manan. Third, Muhammad Adan Afiq bin Muhammad Yuslan. And the last one is me, Muhammad Alif Najmi bin Iswandi. So, what is related rate? Related rate is problem involves finding a rate at which a quantity changes by relating that quantity to other quantities whose rate of change are known. The rate of change is usually with respect to time. Related rate problems involve two or more variables that change at the same time, possibly at different rates. The question should ask us to figure out the rate at which one is changing given sufficient information on all the others. Now, how to solving related rate problem? First, read the problem carefully and write down all the given information. Second, sketch and label a graph or diagram if applicable. Third, find an equation that related the unknown variable and known variable by looking for geometry shape, known formula, ratio such as the Pythagorean theorem, area and volume formula or trigo identities. Next, simplify using appropriate substitution so that chosen equation has only two variables. Then, differentiation the equation implicitly with respect to time. And the last one, substitute all the value into the derivative and solve for the final answer. Now, I will pass to my group member.
My name is Muhammad Iman Syahmi bin Abdul Manan. I'm going to proceed my next presentation. Water storage tank is an inverted circular cone with a base radius of 2 meters and a height of 4 meters. If water is being pumped into a tank at a rate of 2 m³ per minute, find the rate at which the water level rises when the water is 3 meters deep. To solve this question, first we need to sketch the cone and label it. Let V as the cone's volume, R as the surface radius, and H as the water's height at a time T, where T is measured in minutes. We are given that dV over dt is equal to 2 m³ per minute, and we are asked to find dH over dt when the height is 3 meters. The quantities V and H are related by the formula of the cone's volume. See the equation shown below. V equal to 1 over 3 times pi times r square times h. Remember that we want to find the change in height concerning time. Hence, expressing V as a function of h alone is very beneficial. To eliminate r, we use the similar triangles shown in the figure above. R over h equal to 2 over 4. Then simplify r and we will get r is equal to h over 2. Next, substituting the expression for V becomes V is equal to 1 over 3 pi times h over 2 square times h. After we simplify, V is equal to pi over 12 times h power of 3. Next, differentiate each side of the equation in terms of r. dV over dt is equal to pi over 4 times h square dh over dt. So dH over dt is equal to 4 over pi h square times dV over dt. Then we need to substituting h equal to 3 and dV over dt is equal to 2 m cube per minute. We will get dH over dt is equal to 4 over pi 3 square times 2. After we simplify it, dH over dt is equal to 8 over 9 pi. So for the final answer, we will get dH over dt is equal to 8 over 9 pi meter per minute. Next, I will pass it to my group member to continue our presentation.
I'm Muhammad Adam Afiq and I will explain the solution for problem statement 2. Crude oil from an unused well is diffusing outwards in the form of circular film on groundwater surface. If the radius of the circular film is increasing at the rate of 1.2 meters per minute, how fast is the area of the oil film spreading at the instance when the radius is 165 meters? So for the solution, let R and A be the radius and area of the circle, respectively. Take note that the variable T is in minutes. The rate of change of the oil film is given by the derivative dA over dt, where A equal to pi r squared. Differentiates both sides of the area equation using the chain rule. dA over dt equal to d over dt times pi r square equal to 2 pi r times dr over dt. It is given dr over dt equal to 1.2 meters per minute. Substitute and solve for the growing rate of the oil spot. 2 pi r dr over dt is equal to 2 pi r times 1.2 equal to 2.4 pi r, and substitute the value of r is equal to 165 meter to obtain the equation. dA over dt is equal to 1244.07 meters square per minute.
My name is Ahmad Wildan. I will proceed to the next slide. Problem statement 3. The question given, a cylindrical tank with a radius of 10 meter is being filled with treated water at a rate of 5 meter cube per minute. How fast is the height of the water increasing? So, the solution of this question is, let R be the cylindrical tank's radius, H be the height, and V be the cylindrical volumes. We are given a radius of 10 meter and the tank's rate is being filled with water, which is 5 meter cube per minute. So, the volume of the cylinder is provided by the formula below. Use the volume formula of the cylinder to relate the two variables. So, the formula is V is equal to pi r square H. Next, implicitly differentiate each side using the chain rule, and it be dV over dt equals to 2 pi r dH over dt. It is given dV over dt equals to 5 meter cube per minute. Substitute the given rate of change in volume and the tank's radius and solve the increase in height dH over dt of the water. So, it will be 5 equal 2 pi times 10 dH over dt. So, the final answer for this question is the height of water in the cylindrical tank is increasing at the rate of 1 over 4 pi meter per minute. So, the conclusion that we get is, firstly, objectives in these problems are accepted. Secondly, we can conclude that related rates can be applied in many situations. Next, the formula and steps in this problem solving are available to use. And the last one is, We understand what is related rates and known that it can be used in our daily life. So that's all from our group. Thank you. Assalamualaikum warahmatullahi wabarakatuh.